Alright gang, here we go. So this is Chem 1, Unit 6, Part 2. We're talking about sig figs, or significant digits, significant figures. It's awesome and you're going to hate it. Anyway, it's really an important thing. Alright, and we'll kind of talk about it. Now remember in Part 1 we looked at those rulers and we learned about how to make a measurement. Remember when we're making a measurement, we write down all the known values and then we estimate one digit, right? Now, that's an important way of keeping track because that lets people know that that's how precise your instrument that you use to make your measurement, right? So it's a way of scientists to be able to communicate with one another. How good is that number? How accurate is that number that you've used? Or how precise is that number that you've used? All right. So we call these significant figures because those values, the known values plus the one estimated one, are the ones that you can know for sure. Anything past that is no longer significant because it's no longer known for sure. All right, so anything that is what we practice measuring in part 1, those are sig figs. Okay, so whenever we make measurements, we always have to pay attention to the sig figs. Okay, because that's what allows us to communicate to other scientists how precise are we. Okay, so we have to use these measurements all the time in our calculations. Okay, and we need to make sure that our calculated answer is not more precise than what we could actually get based on the numbers that we started with. Okay, so far in chemistry, we've only ever talked about, well, just round it reasonably. And sometimes I've said you really need to round it to like 4 or 5 decimal places, just depending on what we're doing. Now you're going to have hard and fast rules in chemistry that you'll always be graded on to know how am I supposed to round my answer. Okay, and so from now on, you should never ask me, okay, do I need to worry about sig figs? Yes, you do. Okay, chemistry, physics, chem 2. Okay, always have to worry about these guys, sig figs. All right. Now there's 3 rules to sig figs. Okay, all right. First and last rule are super easy. The middle rule is where people get tripped up. All right. So first rule, non-zero numbers are always significant. Always significant. Non-zero numbers. So any number that's not 0. So this guy, 1457, each of these individual digits are significant. They are all important measured values. So this guy has 4 sig figs. Okay, 4 sig figs. All right. Now, zeros is where life gets exciting because zeros can either be a measured number or they can be a placeholder. Okay, so our 3 rules are thus: leading zeros. Okay, so those are zeros that are on the left. They never count as significant. So notice that we've got these 3 zeros here, 1, 2, 3. These are leading zeros. They are placeholders only, so they're never significant. All right, so this guy has 2 sig figs. Okay, sandwich zeros, or zeros that are between numbers, are always significant. So these zeros here, they're not leading, they're sandwiched because there's a 1 here and an 8 here. So these are sandwiched. So this guy here has 4 sig figs in total. Okay, now this is where life gets more exciting. Trailing zeros only count if the number is written with a decimal point. Okay, so trailing zeros, so these are zeros after numbers. So in this case, we've got 100. Okay, 100 here. There's no written in decimal points, so these zeros are trailing zeros without a decimal, so they are not significant. So this guy has 1 sig fig. All right, 1 significant figure. All right, now these guys here, this is the same number, right? You might say, oh, they're both 100. Well, not quite. This decimal point that's right here tells me that these 2 zeros were measured values. So that tells me that these zeros are significant. So this guy has 3 sig figs. See how important that is? This tells me that this number is much more precise than this number is. All right. And then this guy here, well, we have 1, 2, 0.0. Again, trailing zeros with a decimal point. That tells me that these zeros are measured values. Okay, so it's 4 sig figs. Okay, and this rule right here, this trailing zeros rule, is where people get in trouble. All right, so leading zeros, okay, just to recap, leading zeros are never significant. All right, they are always placeholder zeros, so they're never significant digits, and so you just always ignore them. Sandwich zeros are always important because they're between numbers, so they were measured, and then trailing zeros only count if there is a decimal point. All right, then finally the third rule is exact numbers. Okay, they have unlimited sig figs. Okay, so there's 2 types of exact numbers. Numbers that are determined by definition. Okay, so a lot of times these are ratios. So there's, by definition, there's 2.54 centimeters for every inch. Okay, so both of these numbers, this ratio has infinite sig figs. All right, infinite sig figs. All right, or you could say there's 12 eggs in a dozen eggs. That's an unlimited, because that's a defined ratio. So if it's something that we've said as a society, well, this is exactly how many you have in this ratio, this comparison of two numbers, that has unlimited sig figs. And then the other way is when you've counted them. Okay, so counted values, like numbers that you've literally laid out and counted. There's 18 students in the room. You know for sure that you have 18.0000 forever students in the room. Or this example here, you have 3 apples. Okay, there's 3.0000 forever. Okay, so that anything that you've literally laid out and counted have unlimited sig figs. All right, so here we go. So let's just do a bunch of practice problems. We're going to practice these, okay? After I do a couple, feel free to pause the video, do a couple, and see how well you do. All right, so there's no zeros here, so this is easy. This has 3 sig figs. All right, remember non-zeros are each significant. All right, no decimal here, so these trailing zeros do not count, so this has 1 sig fig. All right, let's see here. Now, this one's a mix, right? We got some trailing zeros and we got a sandwich zero. Sandwich zeros always count. Trailing zeros only count if there's a decimal. There's no decimal place, so these zeros don't count, but this zero does. So this has 3 sig figs. You see how that works? I'm just applying a bunch of rules. Leading zeros never count, even if there's a decimal point. Don't get thrown off. Okay, so this guy has 1 sig fig. All right, these leading zeros never count. All right, now this guy, we've got 2 different kinds of zeros. We've got leading zeros and a trailing zero. All right, leading zeros never count, so we'll just go ahead and cross those off. Trailing zeros only count if there's a decimal. Look, there's a decimal right there. So this guy has 2 sig figs. All right, so this guy, same idea as this one above, only this is now a sandwich zero, so don't even really care that there's a decimal point right there. It doesn't help or doesn't hurt though. So this guy's got 3 sig figs. All right, 3 sig figs. This guy, trailing zero with a decimal, so this guy's got 4 sig figs. Now we've got a scientific notation problem. When you're looking at scientific notation values, okay, you're always going to ignore this part when you're figuring out sig fig. This was what makes scientific notation so awesome, is it allows us to keep track of our sig figs. All we have to do for scientific notation is look at our coefficient. However many numbers are in our coefficient, that is how many sig figs you have. So there's 2 numbers, 2 sig figs, okay? And then 222,000, trailing zeros, no decimal point, so this has 3 sig figs, and 22,000 with a decimal point, so 1, 2, 3, 4, 5, 6 sig figs. All right, pretty easy, okay? Now this just kind of goes back to what we were talking about before, okay? Unlimited sig figs are counted objects and exactly defined quantities. We already went into that. And then numbers in scientific notation only count the digits in the coefficient to figure out how many sig figs. Oop, there should be a little time symbol right there. So 4.50 times 10 to the minus 3rd. Anyway, so again, this guy's got 3 sig figs, because we don't care about this at all when we're thinking about sig figs. We just count the numbers in the coefficient. So that's 3.545, 3 sig figs. This is 4.450, so 3 sig figs. All right. Now, this is where life gets a little bit more exciting. Sig figs and calculations. All right. So it's one thing to be able to say, okay, that number has so many sig figs, but that only gets you so far. We're going to be doing a lot of math. I mean, this is chemistry. It's practically a math course. All right. So we're going to be doing a lot of math. And so now we need to know, well, how do I keep track of my sig figs while I'm doing math? Okay, all right, so there's 2 different things you have to worry about. Adding and subtracting have one set of rules. Multiplying and dividing have another set of rules. All right, we'll do a couple of practice problems. All right, so adding and subtracting values. If you're adding and subtracting, your answer should have the same number of decimal places as the number with the least decimals. Okay, so in adding and subtracting, you're paying attention to your decimal places. In multiplying and dividing, you keep track of the number of sig figs. Okay, your answer should have the same number of sig figs as the number with least sig figs. Okay, so in adding and subtracting, you're paying attention to the number of decimals. Okay, so we can say number of decimals. All right, in multiplying and dividing, we're talking about the number of sig figs. All right. So here we go. I'm going to teach you a couple of tricks to doing these. All right. So 170.5 minus 2.33. Okay, so we're going to figure out how to do these. Now, when you're adding and subtracting, the easiest way to do this is just go back to like second grade math when you learned how to do this. So what you're going to do is you're just going to write out your number just like you did, and you're going to line up that decimal. Okay. All right, and you can easily see, well, this is where my number stops, right here. Remember, with adding and subtracting, we look at the least number of sig figs. So you add up that guy with the decimals lined up, and so you say, okay, so this becomes 172.83. Now, my number has to have the same number of decimal places as the least decimal. So this one's only got one decimal place. So my answer can only have one decimal place. So then you have to say, well, I'm going to stop there. This is where life gets more exciting. You have to decide whether or not that number stays the same or whether or not it rounds up. So you look at this 3, and 3 is less than 5, so that means that guy does not round up. So your answer is 172.8. And it would be in meters based on this value here, this unit. All right, 172.8 meters. So that's your correct answer. All right, now let's try another one. Okay, go ahead and pause this and try it on your own real quick. All right, so we're going to line up the decimal, so 145, and then the decimal point would be right there, and then 1.99. All right, we're going to add those guys up, so these get added. So this becomes 146.99. Now this is where my number stops, right? This 145 has 0 decimal points, right? So my number cannot have, my final answer cannot have any decimal points in it. So we're going to have to stop at the 6, and we have to decide, does that 6 round up? Well, that 9 is bigger than 5, so sure it does. Yeah, it becomes 147 meters. All right. Okay, so there's your answer for that guy. All right, so that's adding and subtracting. Pretty easy, right? Just line up those decimals. Multiplying and dividing. Now we're going to look at the total number of sig figs that each number has. Well, okay, so now we got to go back to that previous slide when we figured out number of sig figs. So this guy, sandwich 0, so this guy has 3 sig figs, and I just kind of write out up above them 3 sig figs until I get used to doing them. 3 sig figs here. 3.0 has 2 sig figs, all right? So 3 sig figs, 2 sig figs. That means my answer can only have 2 sig figs. So we're going to take our calculator. We type in 201 divided by 3, and it becomes 67. All right. Now, in our calculator doesn't know anything about sig figs. Okay, so we got to keep track. All right, well, it's 201 divided by 3.0. And in our calculator, it's 67, and the decimals would go on forever. 67.00000. We need to figure out how many zeros to add. Well, we can only have as many number of sig figs as the number with the least number of sig figs. So this guy has 2 sig figs, so our answer just stops there at 67. We don't have any decimals in this number at all. All right. Now, this guy here is the same idea, but we've got scientific notation. Okay, so this guy's got 3 sig figs, no zeros. We don't have to worry about it. This is our coefficient here, so this guy's got 2 sig figs. So again, our answer can only have 2 sig figs. So we'll take 5.11 times 6, and then use your e value to the -3. And so it becomes 0.03066. 0.03066 inches. All right. Now, how many sig figs can our answer have? Well, our answer can only have 2 sig figs because this guy only has 2 sig figs. So we got to figure out, well, where is my second significant digit? Well, leading zeros are never significant, so that 0 doesn't count. That's right here. And we've got this 3, so that's my first one, and then this sandwich 0 would be my next one. So this is where my number is going to stop. Right there, and we have to decide, well, does that number stay as 0? Does it round up? So we look at the 6. 6 is bigger than 5, so yes, it does round up. So our real answer is 0.031 inches. Okay, and if we were going to be really fancy, we'd write this in scientific notation: 3.1 times 10 to the -2 inches. Okay. All right, let's try one more here. So we count up the number of sig figs. So this guy's got 3 sig figs. This guy's got, well, it's got 1 sig fig. Ooh. All right, so now we're going to take 5.35 e to the 5, so e5, and then divided by 0.02. Okay, so it becomes 267.5 and 42340 centimeters. All right, so that's a lot of centimeters, right? Well, how many sig figs? Well, just 1 sig fig, because this number only has 1 sig fig. This is 0.02. So this is where I decide if I need to round or not. Okay, well, 6 is bigger than 5, so yeah, it rounds up. So this becomes 2, becomes 3, and everything else is 0. 1, 2, 3, 4, 5, 6, 7 centimeters. Okay, now that's a lot of zeros. If you write that out on your quiz, I'm not going to be happy, right? The whole reason we had the last part and talked about scientific notation is so we didn't have to count zeros. No, ain't nobody got time for that. So we're going to change this to scientific notation. So we've got 1, 2, 3, 4, 5, 6, 7. So this becomes 3 times 10 to the 7th centimeters. Oops, my face is probably in the way. So this becomes 3 times 10 to the 7th centimeters. Okay? Pretty easy peasy. All right, and that's it. So that's part 2. Nailed it. Do your Sig Fig problems. Hope you love them. The trick to do them is just to do them over and over again. Never forget them. They won't ever go away. Anyway, do your lots of practice problems. Let me know if you have any questions.